Hello, everybody. I'm going to release a new video series in which I'm going to talk about some important and useful tips and tricks for Python programming, which might be of interest to scientists and programmers who typically deal with mathematical operations for a different and various purposes. So, uh, today, the topic that I'm going to talk about is called array referencing. So let's see what is an array referencing. So let's see you are dealing with NumPy arrays in your code. You define an array variable in your code. Then these variables go through a bunch of operation and new definition throughout the code. And later on, it might even happen that you change the value of uh, that NumPy array variable in your code, and then you want to see how that change might impact different operation and other variables that you define in your code. So this topic is called array referencing, and you might come across it quite often if you're coding and you're dealing with NumPy arrays. So the first thing to note here is that NumPy arrays are mutable objects. So what does that mean? So it means that you can change elements or element values of these NumPy arrays anywhere in your code, and that change will be reflected throughout your code. So examples of other mutable objects in Python are listed in dictionaries, whereas immutable objects are strings and tuples in Python. Their values are fixed. You cannot change them uh, in your code after you define them. So this array referencing is very important because, like I said, it can change them. It can impact different operations and variables in your code. So let me illustrate these points by walking you through a number of examples. So let me just give you a very basic example that shows how this array references could become really important. So let me uh, define an array here, simple array, numpy array. So just this is the definition of array one. And then I'm gonna define array two as equal to array one. So uh, we can print the values of both array. So basic definition, we define an array one and it made array two equal to array one. So now let me change an element in array one and see how it would impact array two. So array one, let's change just the first element and equal it to 10. And then let me again change print array one and print array two. So you see that I changed array one, first element in array one to 10. And even though I did not explicitly change array two, the change was also reflected in array two. And that's because these two arrays point to the exact same memory location. This is also called shallow copying. So I'm not changing array two, but I'm changing array one. But because these two array variables point to the exact same memory location, whatever change I make to array two is also reflected in array one. So, if I'm not paying attention to this, it could make impact in other part of my code when I dealing with array one. So let me give you another example to see how this can even vary just very simply. So now instead of changing the first element, let me just give a new definition to array one. So I'm gonna define this from scratch through another array like this. So I'm gonna just run the code from the beginning. So here This is interesting. I changed array one, but even though array one and array two were defined as equal in the first block, when I give a new definition to array one, it didn't impact array two. And that's because this is a totally new assignment for array one. So in this case, array one and array two are not pointing to exact same memory location anymore. Because when I reassign array one here, a new memory location is assigned to array one, whereas array two is pointing to the exact same old um, memory location. So when I make a change in array one, it's not reflected in array two in this case. So let's see other examples. So another important array operation in NumPy is slicing. So if I define array 2 as a slice of array 1, so let's say it's just the first two elements, so like this, and then I'm going to go back to my old example when I'm going to change just the first element. So, and then I'm just run this again. So when the slicing, I'm choosing the first two elements of array 2 and then make that equal to array 1 and make it equal to array 2. And then you see the result here. Whereas here, when I'm changing that value, the first element in array 1, I can clearly see that again, it has an impact on array 2. So slicing also, as we see here, don't change anything. So slicing, when you define array 2 based on even a slice of array 1, and I make changes to array 1, it will also again reflect in the value of array 2. So how can we get around this? So let's say I want to make a change in array 2 and I don't want that to impact array 1. So what I can do here, let me get rid of this slicing operation here. So I can use a copy operation here. If I use a copy operation here, let me run this again. So array 1 and 2 are equal. I make a change in array 1. And as you can see here, this change is not reflected in array 2 anymore, because what copying does is that it creates a copy of that variable. And then array 1 and array 2 are not pointing to the exact same memory location anymore. So by just by using a copy operation, essentially, I will be able to change the value of array 1 without impacting array 2. So this can even get more complex. So because another type of operation that we have in NumPy arrays are essentially masking. So masking, if you're familiar with, it's a type of operation that you use a Boolean array to mask certain elements in an original array, and then you can assign them to a new variable. So let's just see how this array referencing would impact that masking operation. By the way, when we use this copy operation, it's called deep copying as opposed to shallow copying, which I described earlier. So yeah, let's just use some masking operation here. So we have array 1. Let's just make this a bit longer just to illustrate the point. So array 2, well, I defined that based on a masking operation. So I will define a mask, and my mask would be, let's say, array 1 larger than 3, and array 2 would be defined based on this mask. So it would be array 1, and then we have the mask here. So array 1, sorry, yeah. So my array 2 is just the elements that are larger than 3, and it's 4 and 5. So it's what is stored in array 2. So now I can change the mask essentially. So let me just so let's see if do you think if I change the mask, would it impact the value of array 2 or no? So even though they are equal. So let's change this mask to less than 5. So less than 3, essentially. It was greater than 3. Now I change it to smaller than 3. So, and then I'm gonna print those values. So as you see, even though the mask is changed, this array2 value did not change. It's because in masking operation, when I change the mask, it creates a new copy of that array. And it's a totally independent variable. So again, these are not array1 and array2 are not pointing to the exact same memory location. That's why their values are different. So let me also change array1 value and say, let's see if this will change the value of array2 as we saw in the first example. So again, array1 is changed because I changed the first element to 10. You see the clear change when I print array1, but array2 is essentially remains the same. So it's 4 and 5. So I can make this even in the beginning. So I can illustrate this. So I can make this smaller than 3. Now it's 1 and 2. But here I changed, again, you see that there's no change in array2. I changed the first element in array1 as to 10, but the first element in array2 defined through masking remains 1 as the original one. So what masking does, it creates a totally new independent variable. So whatever change you make after masking to that original array would not reflect in new array because they point to different memory location. So as you see this through this example, array referencing could be quite tricky. So you have to really, in summary, what you have to really pay attention to is that whether in each operation, these new variables would point to the same memory point as the first one, the original variable was pointing to. In that case, the value, whatever change you make to your original variable or array, will also be reflected to the new variables and throughout your code, anywhere you have any operation or any variable defined based on your original variable. Whereas in other cases that they are not pointing, you're creating a new instance of them or a new copy of the array, then that change is not reflected throughout your code. So I hope this clarified array referencing topic, and thank you for watching.